Hi, this project is related to Inviscid panel method simulation of airflow over the and NACA 4-digit airfoils using MATLAB. Basically, Inviscid panel method is a simulation of airflow over the NASA 4-digit NACA 4-digit. Okay, airfoils using a MATLAB-based computational framework. In In that method, basically, we have just used cosine space boundary discretization to enhance the numerical stability near the leading and trailing edges. A linear system based source vertex singularity distribution is formulated to satisfy the no penetration boundary conditions and the Kutta's condition, Kutta condition at the trailing edges. So the thing is that in this project, basically, I have just developed the principles of aerodynamics and which discussed through Anderson fundamentals of aerodynamics. So these aerodynamics method are used in the Air Force and Airways company, and this complete technology is used in the airfoils and potential flow field behavior of the airfoil surface. So in the basic of the flights are covered in Anderson's introduction to the flight. Okay. The development of like implementation and accurate computational efficient tools suitable for the aerodynamic analysis, which is best tool is the MATLAB, and that's why I have just developed the complete its viscous and compressible flow modeling in the MATLAB. So here is the abstract with the keywords and introduction, and in the introduction I have just investigated the an efficient way of range of operational conditions with the reliable measurements. Okay, so here is the predicting of the NACA, which is airfoil. That method is used in Karts and Plotkin's low-speed aerodynamics, and from wing theory to panel methods, basically that method is approximate the airfoils surface using a distribution of singularities such as source and vertex, enabling the enforcement of boundary conditions and the computation of surface pressure with the lift as well. Okay. So in the MATLAB simulation, we have just develop the Inviscid panel method and simulate the airflow over the selected NACA 4-digit airfoil. And airflow, basically in the airflow we have just calculated its velocity, its pressure coefficient distribution, its aerodynamic lift alongside the visualization of streamline in the flow field. Okay, so here is the importance of airfoil aerodynamics. Basically, we need to adjust the aeroplane's wings according to the its shapes, its wings, turbines blades, aerodynamic control surface. We need to get the efficient and stability of vehicles. We need to get the machines operating in the fluid environment. So that's why airfoil aerodynamics is one of the most important topic. And we need to check the flow rate. We need to check its the necessary prediction lift, stability, pressure distribution according to the stability of the blades of turbine. Okay, so here is the importance, like this is the theta angle of attack, and like for example for 0 degree and 4 degree angle of attack. So if the angle of attack is increases, it means that the flow of air and the pressure will be increases automatically. Okay. So here is just a panel method theory. Yes, I have just explained how what panel method describes, like how it provide us the modeling approach of incompressible and irrational flow around the streamlined aerodynamic shapes. And in airflow also we need to theoretical aerodynamics introduce some Milne Thompson's theoretical aerodynamics method, and that governing physical conditions need to apply on the no penetrable boundary conditions, which measuring air cannot flow into or out of the airfoil surface. So use of NACA 4-digit, basically this is also I have just explained how we use the research topics in case of geometric formulas, histogram importance in aircraft design, and in aircraft design with the turbines, blade design, with the flight mechanics, with the aeronautics engineering. We need to study about the ideal for numerical modeling because the coordinates along the airfoil surface can be generated precisely. So here is a MATLAB implementation purpose. So basically we have just used the MATLAB to calculate the numerical matrix computation with the data visualization as well as the algorithm development. In the panel method requires the solving of linear equations in generating geometric conditions, coordinates, and producing of two-dimensional flow visualizations basically. So here is a table for parameters used in our MATLAB, and here is a problem statement which I have highlighted the high fidelity computational fluid dynamics methods, and detailed of problem statement is developed. There is a mathematical approach in which I have added all the equations which has been used in that simulation model, which is basically Laplace transform, Gaussian elimination, as well as the tangential velocity, basically tangent velocity. We call it tangent velocity. And here is the methodology, which is basically I have described how I use the MATLAB in terms of geometric coordinates, selected airfoil or generated standard NACA formalization, as well as it defines the camber line, thickness, distribution, final upper and lower surface coordinates. Okay. So here's the design MATLAB simulation with the analysis, and these are the output results for the airfoil geometry panels with 150 panels. Okay. And the pressure coefficient distribution output results are there with the streamlines airfoil as well as the surface tangent velocity distribution. This is a pressure contour around the airfoil, and these are results and discussion with the conclusion as well. Let me just provide you the its MATLAB demonstration. Yes, you just need to run this section and you will get the output results. Estimated circulation and everything. Okay, see, these are the output results accordingly. Let me just, this is the first airflow geometry. This is a CP distribution, basically pressure coefficients. This is the streamlines. These are the tangent velocity, and these are pressure contours. Okay, and these are the output results for the estimated lift coefficient with the estimated circulation gamma values. Okay, so thank you. If you need to ask anything, you just ask, and just contact on the WiredWhite platform. I will answer your all the questions. Thank you.